Hello and welcome, dear travelers, to the Sleepyhead Geographer. Tonight, we find ourselves traveling to the heart of South America, to the high altiplano of Bolivia, where the air is thin and the landscape seems painted with an altitude of over 12,000 feet above sea level, lies something truly magical, a shimmering expanse of white that transforms with the seasons, sometimes appearing as an endless field of crystalline salt, other times becoming the world's largest natural mirror, perfectly reflecting the clouds and stars above. The name Salar de Uyuni whispers of ancient stories. Salar means salt flat in Spanish, while Uyuni comes from the Quechua language, meaning pen or enclosure, as if this remarkable place were nature's own carefully crafted sanctuary. And indeed, it feels like stepping into another world entirely, a place where the normal rules of perception no longer seem to apply. As we settle into our exploration tonight, let's breathe deeply and allow ourselves to be transported to this land of wonder. The Salar de Uyuni covers an area of over 4,000 square miles. That's larger than some entire countries, larger than Lebanon or Cyprus. Imagine driving across this expanse in a 4x4 vehicle, watching the horizon shimmer endlessly in every direction, with nothing but pure white salt crystals crunching softly beneath your wheels. But this is more than just a geological curiosity. The Salar de Uyuni is a living, breathing ecosystem, a place where flamingos gather in their thousands to breed and feed, where ancient islands rise like ships from a frozen sea, crowned with cacti that have stood sentinel for centuries. It's a place where the indigenous people have harvested salt for generations, where modern treasure hunters seek lithium for tomorrow's batteries, and where photographers from around the world come to capture images that seem too surreal to be real. Tonight, we'll discover how this miracle came to be, carved from the bones of ancient lakes and shaped by forces so vast they reshape entire continents. We'll learn about the delicate balance of life that thrives in this seemingly impossible environment. We'll understand why this place captivates everyone who sees it, and why it represents something profound about our planet's capacity for creating beauty in the most unexpected places. The story we're about to share spans millions of years, from the violent birth of mountains to the gentle lapping of prehistoric waters, from the slow accumulation of salt crystals to the sudden magic that happens when the rains come and transform this desert into the world's most perfect mirror. It's a story that connects the deep past with our modern world, showing us how geology and climate, life and death, solitude and community can all come together in one extraordinary place. As we begin this journey together, let the stresses of the day melt away like salt in water. Allow yourself to drift with us across these impossible landscapes, where the sky meets the earth so perfectly that visitors often lose all sense of up and down, where the horizon becomes just a suggestion, and where walking across the surface feels like stepping through the clouds themselves. This is the Salar de Uyuni, Bolivia's mirror of the sky, and tonight it becomes ours to explore. Our story begins not with the salt flat we know today, but with something entirely different. Vast, shimmering lakes that covered this landscape approximately 40,000 years ago. Picture, if you will, a time when the Altiplano was not a stark, high-altitude desert, but a region dotted with enormous bodies of fresh and salt water, their surfaces rippling gently under ancient skies. The lake that would eventually give birth to our beloved Salar de Uyuni was called Lake Minchin by geologists, though it was part of a complex system of prehistoric lakes that included Lake Tauca and Lake Coipasa. These were not small mountain ponds, but massive inland seas comparable to some of today's Great Lakes. Lake Minchin alone is estimated to have been over 200 feet deep in places, its waters a deep blue-green that reflected the towering peaks of the surrounding Andes. Imagine standing on the shores of Lake Minchin on a day 30,000 years ago. The water stretches to the horizon in every direction, occasionally disturbed by gentle waves that lap against rocky shores. Flamingos wade in the shallow areas, their pink feathers bright against the water, while vicuñas and other ancient relatives of today's llamas come down from the mountainsides to drink. The air, while still thin due to the high altitude, carries the fresh scent of water and the distant songs of birds that have long since adapted to this unique, high-altitude environment. But these lakes existed in a delicate balance, one that was slowly shifting with each passing millennium. The Altiplano, that vast, high plateau nestled between the eastern and western ranges of the Andes, was experiencing gradual but profound changes in climate. The region was becoming increasingly arid, with less rainfall to feed the lakes and higher rates of evaporation due to the intense solar radiation at this altitude. The chemistry of these ancient lakes was complex and fascinating. Unlike typical freshwater lakes, they contained high concentrations of minerals that had been washed down from the surrounding mountains over countless years. Lithium, sodium, potassium, and magnesium had accumulated in the water, along with boron and other trace elements. As the climate grew drier and the lakes began to shrink, these mineral concentrations increased dramatically. The process was slow and uneven. During wetter periods, the lakes would expand again, diluting the mineral content and creating temporary respite from the increasing salinity. During drier cycles, the lakes would contract, their edges retreating inward, leaving behind rings of mineral deposits like bathtub rings on a continental scale. Populations would fluctuate wildly, and the ecosystem would undergo constant reorganization as the available habitat expanded and contracted with the water levels. One of the most remarkable aspects of this ancient lake system was its incredible stability in terms of water level, despite the fluctuations. The Altiplano acts as what geologists call an endorheic basin, meaning that water flows into it from the surrounding mountains, but there's no outlet to the ocean. All water that enters this basin must either evaporate or sink into the ground. This creates a natural balance point where evaporation equals precipitation plus runoff from the mountains. As thousands of years passed, the balance began to tip. The climate of the Altiplano was changing, influenced by broader patterns of global climate change at the end of the last ice age. The Andes Mountains themselves were continuing to rise, affecting local weather patterns and creating an increasingly effective rain shadow. Less moisture could reach the high plateau, while the thin air and intense solar radiation at altitude made evaporation increasingly efficient. The shores of Lake Minchin began their long retreat. What had once been deep water became shallow lagoons. These lagoons, concentrated with minerals, became increasingly inhospitable to most forms of life. Only the hardiest organisms, certain types of algae, specialized bacteria, and the remarkably adaptable flamingos could survive in the increasingly salty water. The mineral composition of the shrinking lake was creating something unique. As the water evaporated, different minerals would crystallize out of solution at different concentrations. Gypsum formed first, creating delicate white crystals along the receding shoreline. Then came halite, common table salt, forming thick crusts that cracked and reformed with each cycle of wetting and drying. Finally, in the most concentrated brines, more exotic minerals like sylvite and carnallite began to form. But the most significant mineral accumulation was happening in the deepest parts of the lake bed, where the last pools of water contained staggeringly high concentrations of lithium. This silvery metal, which would one day become crucial for modern battery technology, was quietly accumulating in unprecedented quantities beneath the surface. The final transformation was not sudden. Even as the main body of Lake Minchin disappeared, smaller lakes persisted in the deepest areas. These remnant lakes went through their own cycles of expansion and contraction, sometimes merging during wetter periods, sometimes existing as isolated pools during droughts. Each cycle added new layers of mineral deposits to the growing salt flat. The last of the major water bodies probably disappeared sometime around 10,000 years ago, though smaller seasonal lakes continued to form and evaporate for millennia afterward. By the time humans first arrived in this region, the landscape had already transformed into something recognizable as the ancestor of today's Salar de Uyuni, a vast, flat expanse of white salt crystals, punctuated by a few rocky islands and surrounded by the towering peaks of the Andes. Yet even in its transformed state, the land remembers its watery past. During the rainy season, when water covers the salt flat and creates that famous mirror effect, we're seeing an echo of those ancient lakes. The same forces that created Lake Minchin, water flowing down from the mountains with nowhere to go, still operate today. The difference is that now the water encounters not empty lake bed, but a thick crust of accumulated salt that creates one of the most perfect reflective surfaces on Earth. The legacy of these prehistoric lakes is written in layers throughout the salt flat. Deep beneath the surface, geologists can read the history in bands of different minerals, in fossil remains of tiny organisms that once flourished in the ancient waters, and in the chemical signatures that tell us about changing climate conditions over tens of thousands of years. Every grain of salt on the Salar de Uyuni is a fragment of this ancient story, a crystallized memory of the great lakes that once made this desert bloom. To truly understand how the Salar de Uyuni came to exist, we must journey back even further in time, to the great geological forces that shaped the entire Andes mountain range and created the unique conditions that would allow such an extraordinary landscape to form. This is a story written in stone and measured in millions of years, a tale of colliding continents and rising mountains that transformed an entire region of our planet. The story begins deep beneath the Pacific Ocean, where massive plates of the Earth's crust move with imperceptible slowness across the planet's surface. The Nazca Plate, carrying the floor of the Eastern Pacific, has been sliding eastward and diving beneath the South American plate for over 200 million years. This process, called subduction, is one of the most powerful forces shaping our planet's surface, and it's responsible for creating the entire Andes mountain range. Imagine, if you can, the incredible violence of this process. As the oceanic plate slides beneath the continental plate, it carries with it ocean sediments, water, and pieces of the ocean floor itself. Under the immense pressure and heat deep within the Earth, these materials begin to melt, creating vast chambers of magma that slowly rise toward the surface. Some of this magma erupts as volcanoes, while other portions cool and solidify deep underground, forming the granite cores that will eventually become mountain peaks. The formation of the Andes was not a single event, but a series of mountain-building episodes that occurred over millions of years. Each episode pushed the growing mountain range higher into the sky, creating new peaks while older mountains were worn down by erosion. By about 25 million years ago, the central Andes had risen high enough to begin affecting regional weather patterns significantly, creating the beginnings of the rain shadow effect that makes the Altiplano such a dry place today. The Altiplano itself, that vast high plateau between the eastern and western ranges of the Andes, formed through a particularly intense period of mountain building between 10 and 6 million years ago. During this time, the crust of the earth was literally being squeezed and thickened, pushing the land surface higher while also creating the deep, basin-like depression that would eventually contain our prehistoric lakes. But the formation of the Altiplano involved more than just vertical uplift. The entire region was being stretched and compressed in complex ways, creating a landscape of alternating basins and ridges. Some areas were pushed higher to become mountain ranges, while others subsided to form valleys and depressions. The depression that would eventually contain the Salar de Uyuni was one of these subsided areas, a natural low point surrounded by higher terrain. The volcanic activity associated with this mountain building was extraordinary. The western edge of the Altiplano became a chain of massive volcanoes, some of them among the highest in the world. These volcanoes contributed vast amounts of ash and mineral-rich sediments to the region, materials that would eventually be carried by rivers and streams into the growing lake basins. The mineral composition of these volcanic rocks was particularly important. They contained high concentrations of lithium, boron, and other elements that would eventually accumulate in concentrated brines. As the mountains rose and the basins subsided, the drainage patterns of the region were completely reorganized. Rivers that had once flowed toward the Pacific Ocean found their paths blocked by rising mountain ranges. Instead, they began to flow inward toward the lowest points in the basin, creating what geologists call endorheic drainage, watersheds with no outlet to the sea. This creation of closed basins was crucial for the eventual formation of the Salar de Uyuni. In a normal drainage system, minerals dissolved from rocks by weathering are carried by rivers to the ocean, where they become part of the vast chemical reservoir of seawater. But in an endorheic basin, these minerals have nowhere to go except the lowest point in the basin, where they accumulate in ever-increasing concentrations. The climate during this period of mountain building was also changing dramatically. As the Andes rose higher, they became an increasingly effective barrier to moisture-bearing winds from both the Pacific Ocean and the Amazon basin. The growing mountains created their own weather patterns, with moist air being forced upward and cooling, dropping its moisture on the windward slopes while leaving the leeward slopes, including the Altiplano, increasingly dry. This process is beautifully illustrated today when you travel across the Andes. On the western slopes facing the Pacific, you encounter lush vegetation and frequent rainfall. But cross over the highest peaks, and you enter a different world entirely. The dry, stark landscape of the Altiplano, where rainfall is scarce and evaporation rates are extraordinarily high due to the intense solar radiation at altitude. The thin atmosphere at the elevation of the Altiplano, over 12,000 feet above sea level, creates conditions unlike anywhere else on Earth. With less atmosphere to filter the sun's radiation, the daytime temperatures can be surprisingly warm despite the high altitude. But with less atmosphere to trap heat, nighttime temperatures plummet dramatically. This extreme daily temperature variation creates unique conditions for our mineral crystallization and salt formation. The geological instability of the region also meant that the basins themselves were constantly changing shape. Earthquakes, some of them massive, would periodically alter the landscape, sometimes raising or lowering different portions of the basin, sometimes changing the courses of rivers and streams. Each of these changes affected where water collected and how minerals accumulated. One of the most significant aspects of the geological evolution was the development of extensive groundwater systems beneath the surface. As the mountains rose and the climate became more arid, much of the region's water resources went underground. These aquifers, some of them quite deep, became important sources of water for the surface lakes, and also key players in the mineral concentration process. Groundwater slowly dissolves minerals from rock as it moves through underground formations, carrying these dissolved minerals toward areas of discharge, often the lowest points in basins where lakes form. The volcanic activity in the region also contributed directly to the unique chemistry of the eventual salt deposits. Volcanic hot springs, heated by magma chambers deep underground, bring mineral-rich water to the surface. These springs often have extremely high concentrations of lithium, boron, and other rare elements. As this water evaporates in the arid climate, it leaves behind mineral deposits that are far richer in these elements than typical salt deposits found elsewhere in the world. The interplay between tectonic forces, volcanic activity, and climate change created a perfect storm of conditions for the formation of the Salar de Uyuni. The mountains provided the watershed and the barriers to drainage. The volcanic activity provided the mineral-rich source rocks and direct inputs of concentrated brines. The climate provided the aridity necessary for extensive evaporation and mineral concentration. And the tectonic subsidence provided the perfect basin to collect and concentrate all of these elements. By about 2 million years ago, the basic geological framework was in place. The Altiplano had reached close to its current elevation, the major volcanic activity had mostly ended, and the climate had stabilized in its current arid pattern. The stage was set for the formation of the Great Lakes that would eventually evaporate to create the Salar de Uyuni. All that remained was for time, climate, and the patient work of evaporation to transform a lake basin into one of the most remarkable landscapes on Earth. As we emerge from the depths of geological time and approach the present day, let us now explore the remarkable landscape that these ancient processes have created. The Salar de Uyuni, as it exists today, is a testament to the power of simple processes, evaporation, crystallization, and wind, acting over vast periods of time to create something that seems almost otherworldly in its perfection and scale. Standing at the edge of the Salar de Uyuni, the first thing that strikes any visitor is the sheer immensity of the place. The salt flat stretches away in every direction as far as the eye can see, a blindingly white expanse that seems to merge seamlessly with the sky at the horizon. The scale is so vast that it challenges our normal sense of perspective and distance. Objects that appear to be just a short walk away may actually be hours distant, while the famous rocky islands that dot the landscape seem to float like mirages above the crystalline surface. The salt crust itself is a marvel of natural engineering. Beneath our feet lies a layer of nearly pure halite, sodium chloride, the same chemical compound as table salt, that averages about 10 feet thick, but can reach depths of over 30 feet in some areas. This isn't simply a layer of loose salt crystals dumped on the ground, but a coherent, interlocking mass of crystals that have formed over thousands of years of repeated cycles of dissolution and recrystallization. The surface of the salt flat reveals patterns that are both beautiful and scientifically fascinating. During the dry season, when no water covers the surface, visitors can clearly see polygonal patterns etched into the salt crust. These geometric shapes, ranging from a few feet to several yards across, are created by the expansion and contraction of the salt as temperature changes throughout the day. As the intense daytime sun heats the surface, the salt expands slightly. As temperatures plummet at night, sometimes dropping below freezing even during summer months, The salt contracts, creating a network of cracks that divide the surface into these remarkable polygonal sections. The flatness of the Salar de Uyuni is legendary and measurable. Satellites orbiting hundreds of miles above the Earth use this landscape as a calibration point for their instruments because it provides such a perfect, uniform, reflective surface. The elevation variation across the entire 4,000 square mile expanse is less than 3 feet, a degree of flatness that is virtually unprecedented in nature. To put this in perspective, if the Salar de Uyuni were scaled down to the size of a football field, the variation in height would be less than the thickness of a sheet of paper. This extraordinary flatness is the result of the physics of water and evaporation. When the seasonal rains create a thin layer of water across the salt flat, that water naturally seeks the same level everywhere, just as water in a bathtub creates a perfectly flat surface. As the water evaporates, it leaves behind salt deposits that maintain this same level surface. Over thousands of years, this process has created what amounts to a vast, naturally occurring, precision-leveled surface. The composition of the salt is surprisingly complex when examined closely. While the bulk of the deposit is simple halite, core samples reveal dozens of different mineral species laid down in distinct layers and patterns. Gypsum creates veins of crystalline white that streak through the salt like marble. Ulexite, sometimes called TV rock, for its unusual optical properties, forms nodules that can transmit images through their crystalline structure. Sylvite and carnallite add subtle color variations, creating patterns that range from pure white through pale yellow and pink to deeper salmon hues in some areas. Beneath the main salt crust lies something even more remarkable, a complex layer cake of sediments that preserves the entire history of the ancient lakes. Drilling cores have revealed alternating layers of salt, clay, and sand that correspond to wet and dry periods over the past 40,000 years. These layers are like pages in a book, each one telling the story of changing climate conditions, volcanic eruptions that added ash to the water, and periods when the lakes supported different types of life. The underground structure beneath the salt flat is equally fascinating. The salt crust sits atop a layer of saturated sediments that contain some of the most concentrated brines on Earth. These underground pools of liquid are so salty that they remain liquid even at temperatures well below the normal freezing point of water. The brine contains staggering concentrations of lithium, estimated to represent about 70% of the world's known lithium reserves, along with significant quantities of potassium, magnesium, and boron. The edges of the salt flat reveal yet another aspect of this complex landscape. Where the salt crust meets the surrounding hills and mountains, visitors can see the evidence of changing lake levels written in terraced deposits along the slopes. These ancient shorelines, marked by lines of mineral deposits and wave-cut terraces, show that the prehistoric lakes sometimes stood hundreds of feet higher than the current surface of the salt flat. The color of the Salar de Uyuni changes dramatically depending on viewing conditions and time of day. Under the harsh midday sun, the salt appears blindingly white, so bright that it's necessary to wear sunglasses to prevent snow blindness. During the golden hours of sunrise and sunset, however, the entire landscape takes on warm hues of pink, orange, and gold as the salt crystals act like millions of tiny mirrors, reflecting and refracting the colored light of the sky. The texture of the salt surface varies considerably across different areas of the flat. In some places, the surface is hard and smooth, almost like concrete, allowing vehicles to drive across it at highway speeds. In other areas, particularly near the edges or where groundwater seepage occurs, the surface becomes soft and spongy, with visitors' feet sinking several inches into a slushy mixture of salt crystals and brine. The acoustic properties of the landscape are as remarkable as its visual aspects. The vast open space and hard, reflective surface create an environment where sounds behave in unusual ways. Voices carry for incredible distances, echoing off the salt surface and seeming to come from everywhere and nowhere at once. The silence, when no wind is blowing, can be profound. A deep quiet that many visitors describe as almost tangible, broken only by the occasional crack of salt crystals expanding or contracting with temperature changes. Weather patterns across the salt flat create additional variations in the landscape. Wind, when it blows across the smooth surface, can reach extraordinary speeds with no obstacles to slow it down. These winds sculpt the salt in subtle ways, creating ripples and ridges similar to those found in sand dunes, though made entirely of crystalline salt. Dust devils, small tornadoes of heated air, are common during hot afternoons, creating spectacular columns of swirling salt crystals that dance across the landscape like ghostly dancers. The edges of the salt flat, where it meets the surrounding landscape, provide crucial insights into the ongoing processes that maintain and modify this environment. Here, seasonal streams bring fresh inputs of mineral-rich water from the surrounding mountains. The mixing of this fresh water with the concentrated brines of the salt flat creates complex chemical gradients that support specialized plant communities and provide the conditions necessary for flamingo breeding. During the dry season, the surface becomes a highway for local traffic. The perfectly flat, hard surface makes it possible to drive in straight lines across vast distances, and the salt flat serves as a major transportation route for people traveling between different parts of the Altiplano. Tire tracks crisscross the surface in all directions, though the ongoing processes of salt crystallization gradually erase these marks over time. The modern landscape of the Salar de Uyuni represents a delicate balance between ongoing processes of mineral deposition and the forces of erosion and weathering that slowly wear away the salt deposits. This balance has created a landscape that appears permanent and unchanging, but is actually in constant, subtle flux, with new salt being deposited during each rainy season, while wind and occasional floods slowly reshape the surface features. Perhaps no aspect of the Salar de Uyuni is more magical or more famous than its seasonal transformation from a vast expanse of white salt crystals into the world's largest natural mirror. This remarkable phenomenon occurs during the South American summer months, roughly from December through April, when seasonal rains transform the entire landscape into something that seems to defy the laws of physics and challenge our most basic assumptions about the relationship between earth and sky. The transformation begins subtly, often in late November or early December, when the first tentative rains of the wet season arrive on the Altiplano. These initial showers may seem insignificant, brief afternoon thunderstorms that quickly pass over the vast salt flat, leaving behind only small puddles that evaporate within hours. But as the season progresses and the rains become more frequent and sustained, something extraordinary begins to happen. The key to understanding this transformation lies in the remarkable flatness of the salt surface. Because the entire Salar de Uyuni varies in elevation by less than 3 feet across its entire 4,000 square mile expanse, even a small amount of rainfall creates a uniform layer of water across the entire surface. Unlike other landscapes where rainwater would quickly drain away through valleys and channels, here the water has nowhere to go except up, into the atmosphere through evaporation. As the rainy season intensifies, the thin layer of water covering the salt flat creates one of the most perfect reflective surfaces found anywhere in nature. The water is typically only a few inches deep, sometimes less than an inch, but because the underlying salt surface is so incredibly flat, this thin layer of water creates an unbroken mirror that extends to every horizon. The reflection is so perfect that it becomes genuinely difficult to distinguish between the real world and its reflection, creating a disorienting effect that photographers and visitors describe as walking through the clouds. The science behind this perfect reflection is fascinating. Unlike most reflective surfaces, which scatter light in various directions and create imperfect reflections, the water over the salt flat acts like a perfectly flat mirror. The underlying salt crust provides an ideal foundation. It's white, which means it doesn't add color to the reflected image, and it's extraordinarily smooth and level, which means the water above it forms a perfect plane. The result is a reflection that has almost zero distortion, creating images of such clarity that they rival the reflective properties of manufactured mirrors. But the mirror effect is not constant or uniform across the entire wet season. The quality and extent of the reflection depend on a complex interplay of factors, including rainfall patterns, wind conditions, temperature, and the rate of evaporation. On perfectly still days following a substantial rainfall, the mirror effect can be so complete that visitors report feeling dizzy or disoriented because they cannot tell where the salt flat ends and the sky begins. The weather patterns that create these conditions are themselves remarkable. The wet season on the Altiplano is characterized by afternoon thunderstorms that build up over the surrounding mountains during the day as solar heating creates rising air currents. These storms typically arrive in the late afternoon or evening, often with dramatic displays of lightning that reflect both in the real sky and in the mirrored surface of the salt flat, creating the illusion of lightning bolts shooting both up into the sky and down into the earth simultaneously. The depth of water during the mirror season varies considerably from year to year, and even from month to month. In some years, El Niño or La Niña conditions can significantly affect rainfall patterns, creating either deeper flooding that may last longer into the dry season or reduced rainfall that produces only intermittent mirror effects. During exceptional wet years, the water may be deep enough to support small boats, while in drier years, the mirror effect may be limited to smaller areas or shorter periods. The temperature of the water covering the salt flat creates additional interesting effects. Because the Altiplano is at such high altitude, the air is thin and provides little insulation from temperature extremes. During the day, the intense solar radiation at altitude can warm the shallow water considerably, while at night, temperatures may drop to near freezing even in the middle of summer. These daily temperature swings create convection currents in the water that can sometimes be seen as subtle patterns in the reflection, like invisible rivers flowing across the mirrored surface. Wildlife behavior during the mirror season is particularly fascinating to observe. Flamingos seem to understand the seasonal transformation instinctively, timing their breeding activities to coincide with the rainy season when the conditions are most favorable. Flying over the flooded salt flat, flamingos appear to be flying through the sky both above and below, their pink forms reflected so perfectly that it creates the illusion of birds swimming through clouds. For photographers and artists, the mirror season of the Salar de Uyuni has become legendary. The combination of perfect reflections, dramatic Andean skies, and the surreal landscape creates photographic opportunities that exist nowhere else on Earth. The most famous shots show people appearing to walk on clouds or reach up to touch their own reflections in the sky. During sunrise and sunset, the colored sky reflects in the water, creating scenes where warm colors stretch from horizon to horizon with no clear division between earth and sky. The acoustic properties of the salt flat during the mirror season are as remarkable as the visual effects. Sound behaves differently over the water-covered surface, with voices and other sounds seeming to come from both above and below simultaneously, as they reflect off both the water surface and the sky above. The silence during calm periods can be profound, broken only by the gentle lapping of water against the rare objects that protrude above the surface. The transition periods, when the rains are just beginning or just ending, offer their own unique beauty. During these times, parts of the salt flat may be covered with water while other areas remain dry, creating a patchwork landscape of mirrors and white salt polygons. Islands of salt may emerge from the shallow water like pieces of broken mirror, while channels and pools create complex patterns that change daily as water levels rise and fall. Local weather patterns during the mirror season can create spectacular atmospheric effects. Morning mists sometimes rise from the warm water surface as cool air passes over it, creating ethereal scenes where the landscape appears to be emerging from or dissolving into clouds. Afternoon storms approaching across the mirror surface create dramatic scenes as dark clouds approach their own perfect reflections, doubling the visual impact of the approaching weather. The mirror season also affects the daily rhythms of life in the region. Transportation across the salt flat becomes more challenging when it's flooded, with only certain routes remaining passable. Local salt miners must adjust their activities to work around the flooding, waiting for the dry season to resume their harvesting operations. Tourism patterns also shift dramatically, with the mirror season drawing different types of visitors seeking the perfect reflection photograph. As the wet season gradually gives way to the dry season, usually sometime in April or May, the transformation reverses itself. The rains become less frequent, the evaporation rate exceeds the precipitation rate, and the water level gradually drops. This retreat of the water reveals the salt surface slowly, like a vast white beach emerging from a receding tide. The mirror effect becomes patchy and intermittent, limited to pools and low-lying areas, until finally the entire surface is exposed once again as a blindingly white expanse of salt crystals. The transition from mirror back to salt flat is as magical as the original transformation. As the water disappears, it leaves behind a surface that has been washed clean and re-leveled, ready to begin the cycle again with the next rainy season. The salt crystals, dissolved and redeposited by the seasonal flooding, emerge refreshed and gleaming, their polygonal patterns redrawn with crystalline precision across the vast landscape. This seasonal transformation is more than just a visual phenomenon. It's a fundamental part of the ecosystem that has evolved in this unique environment. The yearly cycle of flooding and drying creates the conditions that allow specialized life forms to thrive, provides the water necessary for flamingo breeding, and maintains the delicate chemical balance that keeps this extraordinary landscape in equilibrium. It's a reminder that even the most seemingly barren places on Earth can harbor cycles of renewal and transformation that rival any ecosystem in their beauty and complexity. Rising from the vast white expanse of the Salar de Uyuni, like ancient ships frozen in a crystalline sea, the rocky islands scattered across the salt flat represent some of the most remarkable and ecologically important features of this extraordinary landscape. These islands, called islas in Spanish, are not merely geological curiosities, but thriving oases of life that provide crucial habitat for unique plant and animal communities that exist nowhere else on Earth. The most famous and largest of these islands is Isla Incahuasi, whose name means House of the Inca in the Quechua language. This remarkable formation rises dramatically from the salt flat, its dark volcanic rock creating a striking contrast against the brilliant white salt that surrounds it. From a distance, Isla Incahuasi appears as a dark smudge on the horizon, but as visitors approach, it reveals itself to be a substantial hill rising nearly 400 feet above the surrounding salt surface and covering an area of roughly 25 acres. The geological story of these islands is intimately connected to the formation of the Andes themselves. These rocky outcrops are the exposed tops of ancient volcanic formations that were created millions of years ago during the intense volcanic activity associated with the rising of the Andes mountain range. When the Great Lakes that preceded the salt flat existed, these formations stood as islands in the water, just as they do today in the Sea of Salt. The shape and composition of the islands provide clues about the maximum depth of the ancient lakes. The current islands represent only the portions of these volcanic formations that were never completely submerged. Isla Incahuasi is composed primarily of volcanic rock, including basalt and andesite that were formed from cooling lava flows. Over millions of years, weathering and erosion have sculpted this volcanic rock into a landscape of dramatic cliffs, hidden valleys, and natural terraces that create diverse microenvironments within the small area of the island. The dark volcanic soil that has accumulated in pockets and crevices of the rock provides growing medium for an extraordinary collection of plants that have adapted to this unique environment. The most spectacular residents of Isla Incahuasi are undoubtedly the giant cacti that crown the island like ancient sentinels. These remarkable plants, primarily of the species Trichocereus passacana, are among the oldest living things in Bolivia. Many of these cacti are estimated to be over 1,000 years old, with some specimens possibly reaching 1,200 years of age. They grow incredibly slowly in this harsh environment, perhaps only an inch per year, but they can eventually reach heights of over 40 feet, creating a forest of columnar cacti that is both beautiful and scientifically invaluable. These ancient cacti have developed remarkable adaptations to survive in one of the most challenging environments on Earth. Their thick, waxy skin helps prevent water loss in the extremely arid climate, while their columnar shape minimizes surface area exposed to the intense solar radiation at this altitude. The cacti store water in their tissues during the brief rainy season, then slowly consume this stored moisture throughout the long dry season. Their root systems spread widely but remain shallow, allowing them to quickly absorb any moisture that becomes available from the infrequent rains or morning dew. The ecosystem of Isla Incahuasi extends far beyond the famous cacti. The island supports a remarkable diversity of plant life, including several species that are found nowhere else in the world. Hardy grasses and cushion plants grow in the spaces between the cacti, while specialized lichens cover many of the rock surfaces, creating subtle patterns of orange, yellow, and green against the dark volcanic stone. Some areas of the island support small shrubs and flowering plants that bloom briefly during the rainy season, creating splashes of color in this otherwise austere landscape. The animal life on Isla Incahuasi is equally specialized and fascinating. Viscaceous, rabbit-like rodents related to chinchillas make their homes among the rocks, feeding on the sparse vegetation and obtaining most of their water from their plant diet. These agile creatures have developed remarkable climbing abilities, allowing them to navigate the steep, rocky terrain with ease. Their soft, dense fur provides insulation against the extreme temperature variations, while their efficient kidneys allow them to survive on very little water. Bird life on the island includes several species that have adapted to the unique conditions. Small finches and other seed-eating birds feed on the seeds of the island's plants, while raptors occasionally hunt from the heights of the island, using the elevated position to scan the surrounding salt flat for prey. During the rainy season, when insects become more abundant, the island may host temporary populations of insectivorous birds that take advantage of the brief period of increased food availability. The smaller islands scattered across the salt flat each have their own unique characteristics and ecological communities. Isla del Pescado, or Fish Island, gets its name from its distinctive shape when viewed from certain angles. This smaller island lacks the towering cacti of Isla Incahuasi, but supports its own community of specialized plants and animals adapted to the salt-influenced environment at its edges. The edges of all these islands, where the rocky formation meets the salt flat, represent some of the most interesting ecological zones in the entire Salar de Uyuni system. Here, the interaction between the solid rock and the salt creates unique chemical and physical conditions. Groundwater seeping from the rocky islands carries dissolved minerals that interact with the salt, creating specialized habitats that support unique plant communities. Some of these edge zones support small areas of salt-tolerant grasses and herbs that can survive the high salinity while taking advantage of the slightly higher moisture levels. Archaeological evidence suggests that these islands have been known to human inhabitants for thousands of years. Pre-Columbian peoples used the islands as landmarks for navigation across the vast salt flat, and archaeological sites on Isla Incahuasi include ancient burial sites and ceremonial platforms that demonstrate the spiritual significance these formations held for indigenous cultures. The name Incahuasi itself reflects the later Inca period, when these islands may have served as way stations or ceremonial sites along trade routes that crossed the salt flat. The islands also play a crucial role in the ecology of the broader Salar de Uyuni system. They serve as refugia, places where plants and animals can survive during periods when conditions on the salt flat itself become too harsh. During the rainy season, when much of the salt flat is covered with water, the islands provide dry land where terrestrial species can wait out the flooding. During the dry season, the islands may provide slightly more favorable microclimates where some moisture can be retained. The geological processes that continue to shape these islands are subtle but ongoing. Weathering by wind, rain, and the extreme temperature variations gradually erodes the volcanic rock, while occasional earthquakes may cause rock falls or alter the drainage patterns that affect vegetation growth. The interaction between the islands and the surrounding salt flat is also dynamic, with seasonal changes in the salt level sometimes exposing new areas around the island bases or covering areas that were previously dry. Visiting these islands provides an otherworldly experience that combines the stark beauty of the salt flat with the surprising richness of life that can flourish in even the most challenging environments. The contrast is particularly striking when visitors climb to the top of Isla Incahuasi and look out over the endless white expanse of salt, broken only by the distant shapes of other islands floating like mirages in the crystalline sea. The temperature differences between the rocky islands and the surrounding salt flat create their own weather patterns. During the day, the dark rocks absorb more heat than the reflective salt surface, creating updrafts that can sometimes be seen as heat shimmer rising from the islands. These thermal differences may also influence local wind patterns and occasionally contribute to the formation of small dust devils or other atmospheric phenomena. Conservation of these island ecosystems presents unique challenges. The slow growth and great age of the giant cacti make them particularly vulnerable to damage, while the specialized nature of the entire island ecosystem means that any disruption can have lasting effects. Tourism, while providing important economic benefits to local communities, must be carefully managed to protect these irreplaceable natural treasures. The scientific value of these islands extends beyond their biological importance. The ancient cacti serve as living records of climate change over the past millennium, with their growth patterns reflecting variations in rainfall and temperature over centuries. The plant and animal communities on the islands provide insights into evolution and adaptation in extreme environments, while the geological formations continue to yield information about the volcanic history of the region. As night falls over the salt flat, the islands take on yet another character. The rocky formations retain heat longer than the salt surface, creating temperature inversions that can trap moisture and create dewfall, sometimes the only source of water available to the island's inhabitants during the long dry season. The elevated position of the islands also makes them extraordinary platforms for stargazing, with the dark skies of the Altiplano providing some of the clearest views of the night sky available anywhere on Earth. In the midst of this vast expanse of salt and seeming desolation, one of nature's most beautiful and remarkable spectacles unfolds each year as thousands of flamingos arrive to transform the Salar de Uyuni into one of South America's most important breeding grounds for these magnificent pink-feathered birds. The presence of flamingos in this harsh, high-altitude environment might seem impossible, but these remarkable creatures have evolved extraordinary adaptations that allow them not just to survive, but to thrive in conditions that would be lethal to most other forms of life. 3 distinct species of flamingos call the Salar de Uyuni home during different parts of the year: the Chilean flamingo, the Andean flamingo, and the James's flamingo, also known as the Puna flamingo. Each species has its own preferred habitats within the broader ecosystem of the salt flat, its own feeding strategies, and its own breeding requirements, creating a complex and beautiful tapestry of pink life against the stark white landscape of salt and the deep blue of the high-altitude sky. The Chilean flamingo is the largest and most numerous of the 3 species found here. These impressive birds, with their pale pink plumage and black-tipped wings, arrive at the salt flat in enormous flocks that can number in the tens of thousands. Their size, they can stand nearly 5 feet tall with their necks extended, makes them particularly striking against the vast, flat landscape, where few other vertical features exist to provide scale. The Chilean flamingos are also the most adaptable of the 3 species, able to feed in a variety of water conditions from fresh to highly saline. The Andean flamingo, distinguished by its deeper pink coloration and yellow legs, is the rarest of the 3 species and is considered near-threatened globally. These birds are specialists, adapted specifically for life in the high-altitude salt lakes of the Andes. Their deeper pink color comes from their diet, which is particularly rich in carotenoid pigments found in the specialized algae and small crustaceans that thrive in the mineral-rich waters of the salt flat. The Andean flamingo's breeding success is closely tied to very specific water level and salinity conditions, making them particularly sensitive to environmental changes. The James's flamingo, the smallest of the 3, is perhaps the most remarkable in terms of its adaptations to this extreme environment. These delicate-looking birds with their pale pink plumage and bright red legs are actually among the most specialized feeders in the bird world, with bills that are perfectly adapted to filter microscopic organisms from highly alkaline water. James's flamingos can feed in water so salty and alkaline that it would quickly kill most other animals, making them the ultimate specialists of the salt flat ecosystem. The feeding behavior of flamingos on the Salar de Uyuni is one of nature's most elegant examples of evolutionary adaptation. Flamingos are filter feeders, using their uniquely shaped bills to strain tiny organisms from the water. The bill is held upside down while feeding, with the bird moving its head back and forth just below the water surface. Inside the bill, a complex system of plates called lamellae acts like a biological sieve, allowing water to flow out while trapping small organisms inside. The food source that sustains these thousands of flamingos consists primarily of microscopic algae, tiny crustaceans, and other small organisms that have adapted to thrive in the extreme conditions of the salt flats' seasonal pools and lakes. The most important food sources include several species of algae that can photosynthesize in highly saline water, small brine shrimp that complete their entire life cycle in temporary pools, and various species of bacteria that actually contribute to the pink coloration that makes flamingos so distinctive. The breeding behavior of flamingos on the Salar de Uyuni is synchronized with the rainy season and the formation of suitable nesting habitat. Flamingos are colonial nesters, meaning they build their nests in large groups that can contain thousands of individual nests. The timing of their breeding is critical. They need the water levels to be just right, with enough water to support abundant food, but not so much that their ground nests would be flooded. The nest-building process is fascinating to observe when conditions are right. Flamingos construct their nests from mud and salt, creating cone-shaped mounds that rise several inches above the surrounding ground level. The top of each cone is hollowed out to create a depression where a single egg will be laid. The construction of these nests requires just the right consistency of mud, wet enough to mold but not so wet that the nest will collapse. The birds use their bills and feet to gather material and shape the nest, often working for several days to complete the construction. The eggs themselves are remarkably large relative to the size of the birds, and both male and female flamingos share the responsibility of incubating them. The incubation period lasts about 28 to 30 days, during which the parents take turns sitting on the nest while the other feeds. The timing must be perfect. If the chick hatches too early in the season, there may not be enough food available. Too late, and the dry season may arrive before the chick is ready to leave the nesting area. When flamingo chicks hatch, they are covered in gray down and look nothing like their pink parents. The chicks remain in the nest for several days before becoming mobile, and even then, they stay close to their parents for several weeks. Young flamingos don't develop their characteristic pink coloration until they begin eating the carotenoid-rich diet of algae and small crustaceans. This process can take months, and juvenile flamingos often appear as gray birds mixed among the pink adults in feeding flocks. The social behavior of flamingos on the salt flat is complex and highly developed. These birds communicate through a variety of vocalizations, from soft muttering sounds during feeding to loud honking calls that can be heard across great distances. The social structure of flamingo flocks involves complex hierarchies and relationships, with experienced birds often leading younger individuals to the best feeding areas. The daily routine of flamingos on the Salar de Uyuni follows predictable patterns that are closely tied to environmental conditions. In the early morning, as the sun rises and begins to warm the salt flat, flamingos typically engage in preening and social activities. As the day warms up, they move to feeding areas where they may spend several hours filtering food from the water. During the hottest part of the day, flamingos often rest, standing on one leg in shallow water or on the salt surface, sometimes with their heads tucked under their wings. The relationship between flamingos and the broader ecosystem of the Salar de Uyuni is complex and important. The birds serve as key dispersers of nutrients, moving minerals and organic matter between different areas of the salt flat through their feeding and nesting activities. Their waste products fertilize areas around nesting colonies, creating localized areas of enhanced productivity that can support other forms of life. The presence of flamingos also creates important habitat for other species. The disturbance created by thousands of feeding flamingos helps maintain open water areas and prevents excessive algae growth that might otherwise choke shallow pools. Small birds often follow flamingo flocks, feeding on insects and other small creatures that are stirred up by the flamingos' feeding activities. The conservation challenges facing flamingos on the Salar de Uyuni are significant and growing. Climate change is altering precipitation patterns in the region, affecting the timing and extent of seasonal flooding that creates suitable habitat. Mining activities, particularly lithium extraction, have the potential to alter water chemistry and availability in ways that could affect flamingo food sources. Tourism, while generally beneficial for conservation by providing economic incentives to protect the area, must be carefully managed to avoid disturbing nesting colonies during critical breeding periods. The flamingos of the Salar de Uyuni also face challenges from habitat changes in other areas where they spend parts of their annual cycle. These birds are highly mobile, moving between different salt lakes and feeding areas throughout the year based on water levels and food availability. Changes in any part of this network of habitats can affect populations that use the Salar de Uyuni for breeding or feeding. Research on flamingo populations in the region has revealed fascinating details about their movement patterns and habitat requirements. Scientists use a variety of techniques to study these birds, including satellite tracking of individual birds, population surveys from aircraft, and detailed studies of water chemistry and food availability in different areas. This research has shown that flamingos may travel hundreds of miles between different salt lakes, following complex routes that take advantage of seasonal changes in water levels and food availability. The spectacle of thousands of flamingos against the backdrop of the Salar de Uyuni represents one of nature's most beautiful examples of life thriving in extreme conditions. When conditions are perfect, during the rainy season when water levels are just right, the sight of vast flocks of pink birds feeding in the mirror-like reflection of the flooded salt flat creates scenes of almost surreal beauty. The contrast between the delicate pink of the flamingos, the pure white of the salt, and the deep blue of the altiplano sky creates a color palette that seems almost too perfect to be natural. As evening approaches and the flamingos settle into their roosting areas, their soft calls echo across the salt flat, a gentle reminder that even in this seemingly barren landscape, life not only survives, but creates some of the most beautiful and moving spectacles in the natural world. Deep beneath the crystalline surface of the Salar de Uyuni lies one of the most significant mineral deposits on Earth, a vast reservoir of lithium-rich brine that contains an estimated 70% of the world's known lithium reserves. This silvery metal, once considered little more than a scientific curiosity, has become one of the most strategically important elements of the 21st century, essential for the batteries that power everything from smartphones to electric vehicles to renewable energy storage systems. The story of how this incredible concentration of lithium came to exist beneath the salt flat is intimately connected to the same geological and climatic processes that created the Salar de Uyuni itself. For millions of years, volcanic activity in the Andes Mountains released lithium-bearing minerals into the environment. Unlike many other elements, lithium is highly soluble in water, meaning it dissolves readily and can be transported long distances by rivers and groundwater. As water carrying dissolved lithium flowed into the closed basin that would become the Salar de Uyuni, the lithium accumulated in the ancient lakes with no way to escape to the ocean. The unique chemistry of the prehistoric lakes played a crucial role in concentrating the lithium to extraordinary levels. As the lakes evaporated under the intense solar radiation and arid climate of the Altiplano, the dissolved minerals became increasingly concentrated. While most minerals precipitated out of solution as the water became more concentrated, lithium remained dissolved even in extremely salty brines. This meant that as the lakes shrank and finally disappeared, the lithium became concentrated in the underground brines at levels far higher than found anywhere else on Earth. Today, these brines lie beneath the salt crust in a complex underground reservoir system. The brines are held in the pore spaces between grains of sand and sediment, creating what geologists call an aquifer, except that instead of fresh water, this aquifer contains some of the saltiest water on Earth, with lithium concentrations that can exceed 1,500 milligrams per liter. To put this in perspective, seawater contains only about 0.17 milligrams of lithium per liter, making the Salar de Uyuni brines nearly 9,000 times more concentrated in lithium than ocean water. The extraction of lithium from the Salar de Uyuni represents both an enormous economic opportunity and a significant environmental challenge. The process begins with drilling wells into the underground brine reservoir and pumping the mineral-rich water to the surface. This brine is then allowed to evaporate in large, shallow ponds, leaving behind increasingly concentrated solutions that are rich in lithium, potassium, magnesium, and other minerals. The evaporation process takes advantage of the same environmental conditions that created the salt flat in the first place: intense solar radiation, low humidity, and steady winds that promote rapid evaporation. The brine is moved through a series of evaporation ponds, each one concentrating the solution further. The process can take 12 to 18 months from the time the brine is first pumped from underground until lithium carbonate is finally precipitated from the most concentrated solutions. The scale of the lithium resource beneath the Salar de Uyuni is staggering. Conservative estimates suggest that the underground brines contain over 9 million tons of lithium, with some studies suggesting the total could be as high as 21 million tons. To put this in context, current global lithium production is approximately 100,000 tons per year, meaning the Salar de Uyuni could supply world lithium demand for nearly a century, even if consumption continued to grow rapidly. But the presence of this enormous lithium deposit also raises complex questions about environmental protection, indigenous rights, and sustainable development. The Salar de Uyuni is not just a mineral resource. It's a unique ecosystem, a UNESCO World Heritage candidate, and a landscape of profound cultural significance to the indigenous communities who have lived in the region for thousands of years. The environmental concerns associated with lithium extraction are multifaceted. The process requires large amounts of water in a region where water is already scarce. While the initial brine extraction uses water that is too salty for any other purpose, the processing facilities require fresh water for washing and other operations. This fresh water must be transported from other sources or extracted from underground aquifers that may also support local communities and wildlife. The evaporation ponds required for lithium processing cover large areas and can alter the visual landscape of the salt flat. These geometric pools, while following the natural process of evaporation that created the salt flat originally, introduce artificial elements into what has been a largely pristine natural environment. The long-term effects of large-scale brine extraction on the hydrology of the salt flat are still not fully understood, raising concerns about potential impacts on the seasonal flooding that creates the famous mirror effect and supports flamingo breeding. The economic implications of lithium development are equally complex. Bolivia, one of the poorest countries in South America, views the lithium deposits as a potential path to economic development and poverty reduction. The revenue from lithium extraction could fund education, healthcare, infrastructure, and other development priorities. However, the benefits of mineral extraction have not always reached local communities in other parts of the world, and there are legitimate concerns about ensuring that the people who live closest to the resource benefit from its development. Indigenous communities in the region have complex relationships with potential lithium development. Some see it as an opportunity for economic advancement and employment, while others worry about impacts on traditional ways of life and the environmental changes that large-scale mining could bring. The salt harvesting that has been practiced by local communities for generations could be affected by changes in the salt flat's hydrology, and the increase in industrial activity could alter the quiet, spiritual character of the landscape that has cultural significance extending back centuries. The global context of lithium demand adds another layer of complexity to the situation. As the world transitions toward renewable energy and electric vehicles to combat climate change, demand for lithium is expected to increase dramatically. The Salar de Uyuni's lithium could play a crucial role in enabling this transition, potentially helping to reduce global greenhouse gas emissions. However, this global environmental benefit must be balanced against potential local environmental costs. Current lithium extraction activities on the Salar de Uyuni are still relatively small-scale compared to the size of the resource and the salt flat itself. The Bolivian government has established a state-owned company to oversee lithium development and has partnered with international companies to develop the technical expertise and markets needed for large-scale production. The approach has emphasized maintaining Bolivian control over the resource while accessing international technology and markets. The technical challenges of lithium extraction from the Salar de Uyuni are significant. The high concentrations of magnesium in the brines complicate the extraction process, requiring sophisticated processing techniques to separate lithium from other minerals. The remote location of the salt flat means that all equipment and supplies must be transported long distances over difficult terrain, increasing costs and logistical complexity. Research into more environmentally friendly extraction techniques continues to evolve. Some proposed methods would use less water, process brines more efficiently, or extract lithium without the need for large evaporation ponds. Advanced technologies such as direct lithium extraction using membranes or other separation techniques could potentially reduce environmental impacts while increasing efficiency. The presence of other valuable minerals in the brines besides lithium adds additional economic potential, but also additional complexity. Potassium can be extracted for fertilizer production, magnesium has various industrial uses, and boron is valuable for glass and ceramic manufacturing. A fully integrated mineral processing operation could extract multiple products from the same brine, potentially improving the economics while reducing per-unit environmental impacts. The long-term future of the Salar de Uyuni may depend on finding ways to balance mineral extraction with environmental protection and cultural preservation. This could involve restricting mining to certain areas while protecting others, developing extraction techniques that minimize environmental impact, ensuring that local communities benefit from development, and maintaining the natural processes that make the salt flat such a unique and beautiful place. Climate change adds another dimension to considerations about lithium development. Changes in precipitation patterns could affect both the natural ecosystem of the salt flat and the operations of lithium extraction facilities. At the same time, the lithium from the Salar de Uyuni could play a crucial role in enabling technologies that help mitigate climate change globally. The scientific research associated with lithium exploration has also contributed to our understanding of the salt flat's geology, hydrology, and ecology. Detailed studies of the underground brine systems have revealed new information about how the salt flat formed and how water moves through the subsurface. This knowledge contributes to better management of the resource while also advancing scientific understanding of similar systems around the world. As the world grapples with the challenges of transitioning to sustainable energy systems while protecting unique natural environments, the Salar de Uyuni represents both an enormous opportunity and a significant responsibility. The decisions made about how to develop this resource will have implications not just for Bolivia and the local communities, but for the global effort to address climate change and the preservation of one of Earth's most remarkable landscapes. In recent decades, the Salar de Uyuni has transformed from one of Earth's most remote and unknown places into a must-see destination that attracts hundreds of thousands of visitors from around the globe each year. This dramatic shift has brought both opportunities and challenges, as the influx of tourism provides crucial economic benefits to local communities, while also creating pressures on the fragile ecosystem and unique landscape that draw visitors in the first place. The rise of tourism at the Salar de Uyuni began gradually in the 1990s, but accelerated rapidly with the growth of social media and digital photography. In the 2000s, images of the salt flat's perfect mirror reflections, the geometric salt formations, and tourists appearing to walk on clouds began circulating globally, creating a viral phenomenon that established the Salar as one of the world's most photogenic destinations. Today, it's estimated that over 300,000 people visit the salt flat each year, making tourism one of the most important economic activities in the region. The majority of visitors arrive during the rainy season, from December through April, when the mirror effect is at its most spectacular. This seasonal concentration of tourism creates intense pressure on local infrastructure and services during peak months while leaving the dry season relatively quiet. The small town of Uyuni, which serves as the primary gateway to the salt flat, has been transformed by tourism from a sleepy railway town to a bustling center of hotels, restaurants, tour operators, and souvenir shops. The typical tourist experience begins in Uyuni town, where visitors join organized tours that take them onto the salt flat in modified 4x4 vehicles capable of handling both the hard salt surface and the shallow flooding during rainy season. These tours have developed into a well-established industry, with local operators offering everything from day trips to multi-day expeditions that include camping on the salt flat and visits to nearby attractions such as colored lakes, hot springs, and flamingo breeding areas. The photography opportunities that draw many visitors to the Salar de Uyuni are truly unique. The combination of the perfectly flat, reflective surface and the lack of visual reference points creates possibilities for creative photography that exist nowhere else on Earth. Visitors delight in taking perspective-bending photos that make people appear giant or tiny, photos where they seem to be touching the clouds, and images where the distinction between Earth and sky completely disappears. But the tourism boom has also revealed the challenges of managing visitation to such a fragile and unique environment. The salt surface, while appearing indestructible, can actually be damaged by heavy vehicle traffic, particularly when the surface is zipped due to moisture or when vehicles venture off established routes. Tire tracks can persist for years in some areas, creating permanent scars on what should be a pristine landscape. The concentration of tourism during the mirror season also creates specific environmental pressures. Hundreds of vehicles driving across the thin layer of water that creates the mirror effect can disturb the perfect flatness of the surface and create muddy conditions that destroy the reflective properties that visitors come to see. The challenge of managing tourist access while preserving the very phenomenon they come to experience requires careful planning and regulation. Local communities have been both beneficiaries and victims of the tourism boom. Many families have found new sources of income as tour guides, drivers, cooks, and hotel operators. The demand for services has created employment opportunities in a region where economic opportunities were historically very limited. Traditional skills such as knowledge of local geography, weather patterns, and safe routes across the salt flat have become valuable assets in the tourism industry. However, the rapid growth of tourism has also brought challenges to traditional ways of life. The peaceful, contemplative character of the landscape that has spiritual significance for indigenous communities can be disrupted by large groups of tourists and the constant traffic of tour vehicles. The increase in waste and pollution associated with tourism requires new approaches to environmental management in an area that had previously been largely untouched by such problems. The environmental impact of tourism extends beyond the immediate effects of vehicle traffic on the salt surface. The infrastructure required to support large numbers of visitors, hotels, restaurants, fuel supplies, water systems, and waste disposal puts pressure on resources in a region where water is scarce and waste management systems are limited. The carbon footprint of transporting hundreds of thousands of visitors to this remote location also raises questions about the sustainability of current tourism patterns. Conservation efforts in the region attempt to balance the economic benefits of tourism with the need to protect the unique ecosystem and landscape that make the Salar de Uyuni so special. These efforts include establishing protected areas, regulating vehicle access to sensitive areas, promoting sustainable tourism practices, and educating visitors about the importance of minimizing their environmental impact. The Bolivian government has recognized both the economic importance of tourism and the need for environmental protection. Efforts to designate the Salar de Uyuni as a UNESCO World Heritage Site reflect the government's commitment to international conservation standards, while also recognizing the global significance of this unique landscape. Such designation could provide international support for conservation efforts, while also potentially attracting even more visitors. Local tour operators play a crucial role in conservation efforts through their daily interactions with visitors and their intimate knowledge of the salt flats' conditions and vulnerabilities. Many operators have developed codes of conduct that emphasize staying on established routes, minimizing disturbance to wildlife, and educating visitors about the ecological importance of the area. Some operators specialize in small group tours that reduce environmental impact while providing more personalized and educational experiences. The development of tourism infrastructure continues to evolve as the industry matures. Higher-end accommodations, including luxury camps and eco-lodges, offer alternatives to the basic tourist facilities that characterized early tourism development. These facilities often incorporate sustainable design principles and environmental management practices that reduce their ecological footprint while providing economic benefits to local communities. The relationship between tourism and other economic activities in the region, particularly salt harvesting and potential lithium mining, creates additional complexity for conservation planning. Tourism operators and conservationists generally favor maintaining the salt flat in its natural state, while mining interests see the underground resources as crucial for economic development. Finding ways to balance these different economic activities while protecting the environment requires careful planning and strong regulatory frameworks. Climate change adds another dimension to tourism management challenges. Changes in precipitation patterns could affect the timing and extent of the mirror season, potentially altering the tourism patterns that have developed around this phenomenon. Extended droughts could reduce the mirror effect, while increased rainfall could create flooding that makes tourism access difficult or dangerous. Educational tourism represents a growing segment that could help align tourism development with conservation goals. Programs that focus on the geology, ecology, and cultural significance of the Salar de Uyuni can create more meaningful experiences for visitors while building support for conservation efforts. Scientific tourism, including opportunities for visitors to participate in research or conservation activities, could provide additional economic benefits while contributing to scientific knowledge and environmental protection. The international attention focused on the Salar de Uyuni through tourism has also increased awareness of conservation needs and challenges. Photography and social media posts by visitors help spread awareness of this unique ecosystem to a global audience, potentially building international support for conservation efforts. At the same time, the global visibility created by tourism has increased pressure on local and national governments to develop effective environmental protection measures. Indigenous communities are increasingly asserting their rights to participate in tourism planning and benefit from tourism development. Community-based tourism initiatives allow local people to maintain greater control over how tourism develops in their traditional territories, while ensuring that economic benefits reach community members directly. These initiatives often emphasize cultural education and environmental stewardship as central components of the tourism experience. The future of tourism at the Salar de Uyuni will likely depend on finding sustainable models that can provide economic benefits while protecting the extraordinary natural and cultural values that make this place so special. This may involve limiting visitor numbers during peak seasons, developing alternative attractions to spread tourism impacts more widely, improving environmental management systems, and ensuring that local communities maintain meaningful control over tourism development in their territories. Research into tourism impacts continues to provide important information for management decisions. Studies of visitor patterns, environmental effects, and economic benefits help guide policy development and conservation planning. International collaboration with other protected areas and tourism destinations provides opportunities to learn from successful conservation and sustainable tourism models developed elsewhere. The story of tourism at the Salar de Uyuni illustrates both the potential and the challenges of tourism as a tool for economic development and conservation in remote and fragile environments. Success will require ongoing commitment to balancing economic opportunities with environmental protection, ensuring that this remarkable landscape remains intact for future generations, while providing sustainable livelihoods for the communities who call this extraordinary place home. The transformation of the Salar de Uyuni from an unknown salt flat to a global tourist destination reflects broader changes in how we discover, appreciate, and sometimes overwhelm the world's most remarkable natural places. As visitors continue to arrive seeking the perfect reflection photo or the spiritual experience of standing in this vast, otherworldly landscape, the challenge remains to ensure that their presence enhances rather than diminishes the very qualities that make this place so extraordinary. As our gentle journey across the Salar de Uyuni draws to a close this evening, let us take a moment to reflect on the profound lessons this extraordinary landscape offers us about our planet, our relationship with nature, and the delicate balance between human needs and environmental preservation. The story we've shared tonight spans millions of years, from the violent birth of mountains to the patient work of evaporation, from the abundance of ancient lakes to the stark beauty of crystalline salt. Through it all, we've seen how the most dramatic and beautiful places on Earth often emerge from the interplay of seemingly simple processes: water and salt, time and climate, life and adaptation, acting over vast scales of time and space. The Salar de Uyuni teaches us about resilience and adaptation. Here, in one of the harshest environments on our planet, life not only survives, but creates spectacular displays of beauty and abundance. The flamingos that gather in their thousands, the ancient cacti that stand as thousand-year-old sentinels, and the specialized communities of organisms that thrive in salt-saturated water all demonstrate the remarkable capacity of life to find ways to flourish even in the most challenging conditions. This landscape also reminds us of the interconnectedness of all things. The lithium that lies beneath the salt, formed by ancient volcanic processes and concentrated by prehistoric lakes, now plays a crucial role in our modern efforts to address climate change through renewable energy and electric vehicles. The seasonal transformation that creates the world's most perfect natural mirror depends on the same forces that shaped the Andes Mountains millions of years ago. The flamingos that breed here connect this remote salt flat to a network of high-altitude lakes across the Andes, creating biological corridors that span entire countries. Perhaps most importantly, the Salar de Uyuni offers us a powerful reminder of the need for wonder and humility in our relationship with the natural world. This is a place that challenges our normal perceptions, where walking across the surface during the mirror season can feel like stepping through clouds, where the horizon becomes just a suggestion, and where the scale of the landscape dwarfs human presence in a way that is both humbling and inspiring. The conservation challenges facing this remarkable place reflect broader challenges facing unique ecosystems around the world. How do we balance economic development with environmental protection? How do we ensure that local communities benefit from their natural resources while preserving those resources for future generations? How do we manage the growing human desire to experience the world's most beautiful places without loving them to death through over-visitation? This Salar de Uyuni doesn't provide easy answers to these questions, but it does offer important perspectives. The indigenous communities who have lived in harmony with this landscape for thousands of years, harvesting salt while maintaining the ecological balance, demonstrate that sustainable relationships with challenging environments are possible. The careful timing of flamingo breeding cycles with seasonal water availability shows us the importance of natural rhythms and cycles in maintaining ecosystem health. As we consider the future of this extraordinary place, we're reminded that every landscape tells a story of change and adaptation. The Salar de Uyuni has been transformed many times over its geological history, from ocean floor to mountain lake to salt flat, and it continues to change today in response to climate patterns, human activities, and the ongoing geological processes that never truly stop. But within this context of constant change, there's also a deep stability and permanence that can provide comfort and perspective. The ancient cacti on Isla Incahuasi have stood through centuries of drought and flood, political upheavals and social changes, bearing witness to the longer rhythms of the natural world that continue regardless of human concerns. The seasonal cycle of mirror and salt, flooding and drying, continues as it has for millennia, connecting us to processes that are both ancient and ongoing. Tonight, as you drift towards sleep, perhaps you can carry with you some of the vast quietude of the Salar de Uyuni, that profound silence that visitors often describe as almost tangible, broken only by the gentle sound of salt crystals adjusting to temperature changes or the distant calls of flamingos settling into their roosting areas. In our busy, noisy world, there's something deeply restorative about contemplating such a place of silence and space, where the concerns of daily life seem to dissolve like salt in water. The mirror of the sky that gives the Salar de Uyuni its poetic name offers us a final metaphor to consider. When we look into that perfect reflection during the rainy season, we see not just the sky above, but our own small place within the vast cosmos. We're reminded that we are part of something much larger than ourselves, part of the same natural processes that created this extraordinary landscape, part of the same planet that supports both the extremophile bacteria in salt-saturated pools and the urban environments where most of us make our daily lives. As we conclude our visit to this mirror of the sky, let us carry with us the sense of wonder and possibility that such places inspire. In a world that often feels fragmented and troubled, landscapes like the Salar de Uyuni remind us of the underlying unity and beauty that still exist in our natural world. They inspire us to protect and cherish the remarkable planet we share, and to approach the challenges of conservation and sustainability with both the patience of geological time and the urgency of our rapidly changing world. Sleep well tonight, dear listeners, with visions of endless white salt crystals, perfect mirror reflections, and pink flamingos dancing against the vast blue sky of the Altiplano. Dream of a place where earth and sky become one, where silence speaks volumes, and where the ancient and the eternal continue their patient dance across one of the most beautiful landscapes our planet has ever created. Good night.